What appealed to you when they first pitched you the idea?
Bigger is better. Bigger is better in radio astronomy. The signals in radio astronomy are so weak that you need big telescopes to see it. And where's my mobile phone? One of those is millions of times stronger than the natural signals from space. So we need huge collecting areas to study the distant universe.
But FAST isn't just about the size, is it? Can you tell us about some of the modern technologies involved in the design of FAST?
Yes, it's a very clever idea because it was based upon the idea in Puerto Rico, Arecibo telescope, which is a fantastic precursor, showed the way to go. But that has difficulties because it is actually purely spherical. It's purely a bowl. And that means that at the focus point over the bowl, the focus is very complicated and it weighs 1,000 tons. The clever idea in China was to say, well, let us make the surface change. Let us pull on the surface to change it into a shape that focuses at a single point. And that was a brilliant idea. And today we've seen, walking around the telescope, how wonderful it's been carried out.
Now that the telescope is going to start operation soon, what kind of things will it be looking for?
Well, a whole range of things, but particularly, there are two things particularly that it will do better than any other telescope in the world, at least until the square kilometre comes on 10 years from now. One is to study the radiation from the simplest element in the universe, which is hydrogen gas, all through the universe. And it tells us all sorts of things about the way things are moving in the universe. It's a diagnostic, it's a tracer. So a hydrogen in the universe is the big thing. And the second big thing is pulsars and things going bang in the sky. Turns out they are the most accurate clocks in the universe. And if you can measure enough of these clocks, because they're going pulse, 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 it enables you to look for gravitational waves, one of the predictions of Einstein's general theory of relativity.
Why is it important to detect these gravitational waves?
Because it's man's curiosity. It's fundamental physics. We want to understand how this universe which we live in is put together. And one of the most beautiful theories, one of the most successful theories, is the theory of gravity by Einstein, general relativity. And we want to see why that is wrong. Because it must be wrong, because it doesn't fit in with other theories of physics, quantum mechanics.